All right, these are the blank notes. I hope you got them printed out. If you're able, let's look them over. When two parallel lines are intersected by a third line, let's stop right there and look at the picture. Here's two lines that are marked as being parallel to each other. We do not assume that lines that look parallel really are parallel, just like we don't assume right angles, and we don't assume isosceles triangles. But these are the marks that you need to see unless there is some kind of statement in the problem telling you that a couple of lines are parallel. So parallel line marks are usually a double set of arrows, pointing in the same direction. Not usually a single arrow. Sometimes I might get lazy or careless or a little sloppy, in fact, and only write a single arrow, but I try to be careful and always use double arrows. So these double arrows tell you the lines are parallel. And then the third line, the one non-parallel line, is called a transversal in this context, okay? Trans means across. You may be familiar with terms like the Transcontinental Railroad, which was a railroad that transed the continent or crossed the continent. Or some of you, I'm sure, have flown transatlantic flights. You've gotten on an airplane and flown transatlantic or across the Atlantic Ocean. So a transversal is a line that crosses to others. Don't ask me where the root versal is coming from. I don't really know. But anyway, this third line is the transversal, and these two are the parallels. Back to the sentence. When that is happening, there are 8 angles that are formed, right? 1, 2, 3, 4 angles around this intersection, and 1, 2, 3, 4 more angles around this intersection. And when the lines are parallel, then all 4 of the, I'm going to say, acute looking angles will be congruent, and all 4 of the obtuse looking angles will be congruent. Certainly, just among these 4 angles up here, these 2 acute looking angles will be congruent because they're vertical angles, and we've already proved that in a previous lesson. So if we're calling this angle A, we can call that angle A. If I'm calling that angle O for obtuse, then that angle's measure would also be obtuse, right? But then when this line is parallel to that one, then these 4 angles match these 4 angles measure by measure. So these 2 acute looking angles would be the same size as these 2, and these 2 obtuse looking angles would be the same size as those 2. So among these 8 angles, there are only 2 different angle measures, right? So we fill this in here. All the angles marked A are acute or are congruent. All the angles marked O are congruent. Now it's possible, of course, if you have 2 parallel lines, that you have a transversal crossing them in such a way that there are no acute angles and no obtuse angles, but rather every single angle is a right angle. I mean, here, if I mark these lines parallel and I put one single right angle mark in that diagram, now you know that every single other angle in this picture is also got to be a right angle. There's no acutes, there's no obtuses, right? All right, so any pair of angles, therefore, this is still going back to the very first sentence. When 2 parallel lines are intersected by a third, 8 angles are formed. 4 of the acutes are congruent, the 4 obtuse looking angles are congruent, and therefore any pair of angles, you pick any 2 angles out of these 8, and those 2 angles, guaranteed, they're either going to be equal to each other, that is congruent, or they're going to add up to 180 degrees, or in a word, they're going to be supplementary, right? Because, I mean, imagine we picked these 2 angles side by side. They would be supplementary, right? But what if we picked this acute angle and that obtuse angle way down there? Would they be supplementary? Well, sure, because that obtuse angle is going to be congruent to that obtuse angle. So if you can add this acute angle to that one to get 180, you can certainly add it to that one to get 180. or for that matter, to this obtuse angle and get 180. Right? So this is key here to doing a lot of the homework problems tonight. So in some of the homework problems require no algebra. They're very straightforward. They're asking you to find a bunch of angle measures in a diagram. Here's a diagram, for example, with lines that are marked parallel. And so therefore, if this angle is 130 degrees, which other angles in this diagram would also be 130 degrees? I'll give you 5 seconds to think about that. Which other angles would be 130 degrees? Got it? 130 degrees is obtuse. It certainly looks obtuse. That angle there, B, that angle there, F, that angle there, D, B, F, and D, all 130 degrees. And then the A, the E, the C, and the G would all be 50 degrees, right? Now, if these lines were not marked parallel, pay attention here. These lines were not marked parallel, and I told you this angle measures 130 degrees. You could still determine the measures of angles A, B, and E, or I should say, the size of the value of those variables. You could still determine that this is 50, this is 130, and this is 50. You just wouldn't know anything at all about these 4 angles down here. That makes sense? Just because these lines aren't parallel, that has absolutely no impact on the size of those angles. This line being parallel to that one now connects these 4 angles to those 4. But whether this line is parallel or not, if I tell you one of these 4, you certainly know the other 3 very quickly. Number 2, now this one's going to take some algebra here to answer some questions that I might ask, okay? I might ask for the measure of this angle here or the measure of that angle there, which have no algebraic expressions in them at all. But when you come upon these diagrams that have algebraic expressions, you're going to need to set up an equation. And the equation is going to be based on one of 2 facts. Either the 2 angles that I've marked must be equal to each other, and so you'll set up an equation with one expression on one side and one expression on the other. Or it's possible that I've chosen 2 angles that must add up to 180. And so you'll have equals 180 on the right, and you'll have the other 2 expressions being added together. So which kind of equation is it going to be in this diagram here? Well, here's where I would strongly urge you to use your visual judgment. It can be very helpful here. Now, I've been sternly warning you not to use your visual judgment all semester long, but I've been saying there are rare occasions where it comes in useful, and here's one of those rare occasions. Since these lines do in fact look parallel, oops, you know what? I forgot to mark them parallel. Shame on me. Without parallel marks, there's nothing that we can know about the measure of this angle and this angle and how they compare to each other. I'm missing it. Let's add those marks to that picture, shall we? Because I really meant for those to be there. Okay. So these angles certainly look parallel. So this is not a bad looking picture. Okay. This angle certainly appears to be obtuse, considerably larger than 90. How about this angle down here? Also obtuse? Or does it look more acute? Well, it looks acute, doesn't it? One acute angle, one obtuse angle, definitely not equal to each other. And therefore, they must add up to 180 degrees. So I would begin solving any questions having to do with this diagram by writing x plus 3x equals 180. If you solve that equation, you'll get x equals 45. And then if I asked for the measure of this angle, you could tell me. This angle, you could tell me. Really, any angle. If I asked for any angle in this diagram, you could tell me its measure now, because if this one's 45, so is that one, so is that one, so is that one. All the acute angles would be 45. And all the obtuse angles would be 135. Okay? In problem number 3, I did mark the lines parallel to each other this time. Okay. Acute or obtuse. You're using your visual judgment here. This is what you've got to train yourself to ask yourself. Okay, if you get to a problem like this in the homework or on the quiz and you have no idea to begin, I get it. It would be because you haven't trained yourself to ask yourself this question. Are these two angles congruent to each other, or are they supplementary to each other? Because it's guaranteed to be one of the two when the lines are parallel. Well, this angle appears to be acute. Based on our visual judgment, this angle also appears to be acute. So if they're both acute, those angles must equal each other. And there's how I would begin to solve this problem. Again, students who ask me, I don't know how to do this problem. What do I do? They're usually in a hurry to find out whether they should add, subtract, multiply, or divide things. But the first thing to do is to recognize the relationship between the angles and write an equation. Then algebra tells you what to do after that. If you solve this equation, you'll get x is equal to 10, and you could plug that 10 back in to find these angle measures and then any other angle measure in the picture. Okay. Last diagram, number 4. Now, these lines are not marked parallel, and I meant for them to not be marked parallel. So is there anything that we can know about these two angles that are side by side here? Well, yes, we still can. These two angles are still what we call a linear pair. You remember that phrase, right? A linear pair is a pair of angles that are side by side, forming one perfectly straight line together. And therefore, they must be supplementary. They must add up to 180 degrees. And then you could solve that for x. You would get x is equal to 56.6 repeating, to be exact, or 170 thirds as a fraction. And then you would know the measure of this angle and the measure of this angle by plugging x back in. And you would know the measure of these two angles here. You could find those also, but you just wouldn't know anything about any of those 4 angles over there because we don't know that that line is parallel to this one. Okay? Now that should really be enough. I wish you well with the homework. See you later.